When two or more linear equations are considered at the same time, the equations are called systems of linear equations. The solution to a system of linear equations consists of the values for the variables that make all of the equations in the system true. One method for solving a system of linear equations is called the addition method. To use the addition method, you want to be able to add the equations and have one of the variables to drop out. So in this first system of equations, if I add the equations, the y's will drop out. So I'm left with an equation in just one variable. Okay, so solving for x, I get x equals 3. To find the value for the other variable, just pick one of the equations. It doesn't matter which. I'm going to pick the first one. I'll replace x with the value for x that we just found. Okay, and solve for y. I get y is equal to 1. So when x is 3 and y is 1, we'll make both equations a true statement. I'll write my answer as an ordered pair. So in parentheses, I want x first, comma, then y. Now the second equation, the second system of equations. If I add them right now, neither the x's or the y's to drop out. So I'm going to pick a variable. Let's eliminate the x's. If in one equation I have a 2x and the other equation I have a negative 2x, I could get the x's to drop out. Well, the first equation I have a 2x, so I'll just keep that equation as given. To get a negative 2x in the second equation, just multiply each term in the equation by a negative 2. So I have negative 2x minus 6y equals negative 36. Now when I add the equations, as planned, the x's drop out. I'm left with a negative 5y equals a negative 25. Solving for y, I find that y is equal to 5. Now to find x, pick either of the other equations. I'm going to pick the equation where the coefficient of the x is just 1. So I'll pick the second equation, x plus 3y equals 18. And I'll replace the y with 5. So x plus 3 times 5 equals 18. So x plus 15 equals 18. Subtract 15 from both sides. I get x equals 3. So when x is 3 and y is 5, I'll get a true statement for both equations. So I'll write my answer as an ordered pair. In parentheses, I want x first, which is 3, comma, then y. Now in the third example, when I add these, neither the x's nor the y's will drop out. So I'll pick a variable to work with. I'm going to pick x because the coefficients of the x are smaller than the coefficients for the y. So 3x and 2x will both go into 6x. So if I can get the first equation to be, let's say, a positive 6x, and the second equation to be a negative 6x, when I add the equations, the x's will drop out. To get that first equation, the 3x minus 5y equals negative 6, to have a positive 6x, I need to multiply each term in that equation by 2. To get the second equation to lead with a negative 6x, I need to multiply each value in that second equation by a negative 3. So what I'll end up with is 6x minus 10y equals negative 12. The second equation, I'll have minus 6x minus 12y equals a negative 54. Now when I add the equations, the x's dropped out as planned. I have a negative 22y equals a negative 66. Divide both sides by negative 22. I get y equals 3. So to find x, I'll pick either of the other equations. It doesn't matter which. So if I pick the first equation, 3x minus 5y equals negative 6. I'll replace y with 3. So I have 3x minus 5 times 3 equals negative 6. So 3x minus 15 equals negative 6. I'll add 15 to both sides. I have 3x equals 9. X equals 3. So if x is 3 and y is 3, both of those equations will be true statements. As an ordered pair, in parentheses, I'll do x first, comma, then y. So 3, comma, 3. Okay, the last example. If I add these equations right now, neither the x's nor the y's will drop out. So I'm going to pick a variable. I'm going to pick y. I'm going to try to eliminate the y's. I picked y's because the coefficients for the y's were smaller than the coefficients for the x's. So if I have a negative 2y in the second equation, if I have a positive 2y in the first equation, the y's will drop out. So I'll multiply that first equation by 2. And since the second equation already has a negative 2y, I'll just add it to that. So what I have is 8x plus 2y equals 12. Adding that to negative 8x minus 2y equals 13. Well, when I add these equations, well, the y's drop out as planned, but so do the x's. So I end up with 0 equals 25. Well, 0 can't equal to 25. So what we get is called a contradiction. There's no solution to this equation.